All right, algebra students. Yesterday we talked about x and y intercepts, which was a very quick topic. And so today we're going to jump into what our next topic is going to be, which is more of the main focus of this unit. And it's going to be called line of best fit. Now, that's probably what I'm going to refer to it mostly. There is another name for this, and it's actually, we'll put it in parentheses, it's linear regression. And so that's the fancier name for it. Line of best fit, I think, describes better what we're doing. But just know that you'll have it referred to as either one, line of best fit or linear regression. So the first thing I want us to look at is what a scatter plot of data is. Scatter of data. So a scatter plot of data. And so let's just think about what a scatter plot is, this word scatter plot, and what it means to have data. So data is going to refer to real world situations where we're given some numbers that are related to each other. And so a scatter plot looks something like this. So you're going to have basically what would be an x and y axis. And you're going to have some data or some real world situation numbers that are related to each other. So let's think about calling the x-axis age. So let's think about these being ages. So like age 1, age 2, age 3, age 4, age 5, age 6. And you can fit however many lines you need to in there because we're not doing this exactly. But let's also think about compared to height. So I'm just going to make some tick marks up through here. So let's think about in general, what happens as you age? Well, as your age increases, so if this is like newborn, 1 year old, 0, all the way up to 6 years old, when you are very young, you are also very short, right? And so your height is very low down here. But as you age, of course, in the next year, maybe you're a little taller. And the next year, maybe you hit a growth spurt and you're really tall. And then the next year, maybe it goes up even more. And, maybe the next year you don't grow as much, but you grow a little bit. And so what we mean by a scatter plot of data is just that we have some data that are related to each other in a certain way. And it might not be in a straight line, right? But we just have these data points that are plotted on an x and y axis showing the relationship between age and height. And now what we mean by a line of best fit is what we can do is we can actually draw a line that goes through this data. Now, it's not going to hit every point, but it is going to give us a general idea of the direction that the data is going in, right? Because again, as you age, you are going to get taller. Now, of course, there's going to come a point where you don't get any taller, right? But in general, when you're younger, you're shorter, and as you grow, you are increasing in age. Now, we could also look at, maybe a set of data that looks like this. So again, another x-axis, another y-axis. And let's make the y-axis a size of a pizza. And let's make the x-axis time. So as time goes on, if you have a pizza sitting in front of you, as your time increases, so at the very beginning of the time a pizza is set in front of you, you've got pretty much the whole pizza, right? So the size of the pizza is very large at the very beginning. So we're going to put a data point up here. But of course, as time goes on, what happens? Well, you eat a slice and the size gets less. And then as time goes on, maybe somebody eats a lot more. And then maybe somebody eats another piece and it gets a little smaller. And so as time goes on, the size of the pizza actually is going to decrease. And I'll just put some more points there. And so your line of best fit could either have positive or negative slope, or, of course, depending on your data, it may have zero slope or undefined slope. But just in general, that's what a scatter plot is. It's just a bunch of data points on an x and y axis. And a line of best fit is a line which goes through approximately half of the data. So notice on both of these lines, I've got some points above and below. And actually, maybe we should put a point right here just to make a point. Above the line and below the line, so that the line pretty much goes through the exact halfway point of this data. And so in general, what a line of best fit is, so let's write a definition. A line of best fit, we'll underline that, is a line, of course, which models the general pattern of a data relationship. And in this case, you know, we had a relationship between age and height and a relationship between time and size of pizza. It can be used, and this is going to be so important, so put a star next to this. It being the line of best fit, it can be used to predict future values. Oops, if I could spell values. All right. And so predicting future values is really going to be part of the point of a line of best fit, because guess what? You know, I've got data here from 1-year-old, 2-year-old, 3-year-old, 4-year-old, 5-year-old, 6-year-old. But what if I wanted to know something about, you know, I don't know, 10-year-old way out here? Well, what I could do is I could follow, you know, wherever 10 is out here, I could follow a line straight up and find where my line of best fit is going to intersect it. And that will give me a good idea about my height at a particular age. And so that's what we mean by predictions. And we're going to look at that a little more closely in the next piece of information that we're going to write down. So here's what I think is really fun about this. What you're going to be given is you're going to be given some data. And Desmos is really helpful for finding a linear regression line of best fit. So we're going to be using Desmos. So I'm going to write down use Desmos, just like we did yesterday for X and Y intercepts. We're going to do a lot of typing in Desmos for this. So our first step is going to be to enter data. And of course, we're doing this in Desmos. Now, we need some data first, right? So I'm going to give you just some data. So we're going to be given some X values and some Y values. Now, we could make up a story about what these values actually mean. So I'm going to do 1.7, 10.4, 3, 12.1, 4.7, 13.7, 6, and 15. And so we'll stop right there. So let's just say, I don't know, what kind of story could we make up about this data? Maybe this is hours. This is hours, and maybe this is distance. I don't know. Distance that you rode a scooter. I don't know. Does that make sense? It took you 1.7 hours to ride a scooter 10.4 miles. Maybe your scooter's probably going pretty slow. Maybe this is more like a skateboard or something. We'll just say that this is hours versus the distance that you've rode on a scooter. All right, now, rather than using our poor drawing skills to draw out a scatter plot, we're actually going to input this into Desmos because Desmos will plot it for us. So I'm going to open up my Desmos calculator. And this will, of course, I'm doing this on a tablet just to show you, but this will also work on your laptop. And so what you're going to do in order to input this data is you're going to go to this plus sign. Now, it may be, if you're on your computer, it may be in a different place, but you want to look for the plus sign that is right above the equation editor, not on the graph, but on the place where you're typing in stuff. So click on that, or press it. And we're going to click on actually this button that says table. So this is actually insert, something new. And you can insert a lot of different things in Desmos: an expression, a note, a table, a folder, or an image. I want a table. So we're going to insert a new table. Now notice at the top of your table it says X1 and Y1. You want to be careful as you're doing this, and you want to always make sure that this says X1 and Y1. And so we're going to look at the data that we are given, and we're going to type it in. So our data for this particular set of comparisons is 1.7, and then I'm going to click over here into the Y, and the Y value that goes with that is 10.4. And notice it is plotting a point over here. It plots a point at 1.7, 10.4. All right, the next one is it takes us 3 hours to ride our scooter 12.1 miles. Maybe this is, maybe we had to stop for ice cream or something. All right, then 4.7 hours and versus 13.7 miles. And then we've got 6 hours, and then the number that's going to go with that is 15. So these are the numbers that I'm given, and all I do is I insert them into Desmos. Now again, I want to caution you and make sure your table should always say X1 and Y1. All right, now notice if I go down here and if I were to insert a new table down here, do you see how this bottom number here changes to 2? We do not want it to say 2. That's going to throw off what we're going to do in the future. So if that ever happens, you can actually click up here and you can backspace, and you always want to make sure that that subscript there is 1. Now, it doesn't like that I have 2 X1s now, so I'm going to back that out. But again, you just want to make sure that you always have X1 and Y1 as your headings in your table. All right, so we go over here in our graph and we see that we actually have some data points, and they're kind of linear. We can tell that this general pattern is probably going in an upwards direction. That the more hours we spend going somewhere, the further distance we go. That makes sense. And so what we want to do is we want to put a line of best fit through this, because if you'll notice, even though these look like they're kind of linear, they're actually not in a straight line, right? There's a little bit of a curve here. And what we want to do is we want to get a line of best fit that goes approximately through them. Not exactly through them, but approximately. So there is a general regression formula that you can type in Desmos that will do this for you. Now I'm going to go back over here and I'm going to write it down for us first before we actually type it in. And so the general regression form. So the first thing we've done here is enter our data. Step 2 is to type regression formula. And here's what that regression formula looks like. And it's going to remind you, and I'll write this up above here, it will remind you of y equals mx plus b. However, it looks a little different. So here's the regression formula. It's going to be y1. So we're going to type in y1. And then we're going to type in an approximation symbol, which kind of is like an equal sign, only it's one line and it's curly. So y1, and then approximately, because remember, this line is not going to be exact. And then we're going to put m, and then it's going to be x1. And this, the y1 and x1, remember, refer back to our table. That's why we want those headings to be x1 and y1. But it's still just input and output. And then it's going to be plus b. So it looks very similar. The regression formula, and I'm going to put a cloud around that because I need to remember it. The regression formula looks very similar to y equals mx plus b. The only difference is that the x and the y have ones below them, and also we use this squiggle mark, this approximation symbol, instead of an equal sign, all right? So I'm going to go back over here to Desmos, and I'm going to show you how we're going to type that in. So we've still got our data in here. We've still got our scatter plot, and we're going to type in. And now watch how I'll move this down a little bit so you can actually see what I'm typing in on the keyboard. Can I zoom out just a little bit? Yeah. All right. So I want you to see what I'm typing in. So I'm going to hit Y. Notice that comes up here. I'm just going to hit the number 1. That makes it a little subscript below it. Then I'm going to have to click over here next to it because I want out of that subscript. And then I'm going to hit the ABC button down here in the corner because I don't see any little squiggle marks here. But the little squiggle mark is actually down here at the bottom of the alphabet keyboard. And so we're going to hit that little squiggle. It comes up here. Remember, that's in the ABC menu. I'm going to click back on 1, 2, 3 to take me back to my numbers. Then I'm going to hit M. Oh, no, I'm not. I'm going to go back to the alphabet because I need an M. M. Now I'm going to go back to the alphabet, or the numbers, because here's my X. X1. Remember, we want a 1 next to our X. And then it's going to be plus B. And we go back to the alphabet menu, and we hit B. And notice, as soon as I hit that B, what happens? There's a line that pops up through my data points. Now, you also might notice here that there is a little bit of information that we are given. So again, this is our line of best fit. This is our linear regression formula. It gives us the line of best fit that goes through the data. Notice it doesn't go exactly through the data, right? The data is, some of it's below, some of it's above, some of it actually looks pretty close to. And so these numbers over here that we're given, these R values, we're not going to talk a lot about R values, but this is basically the percentage of which the line fits the data. So look at the percentage here. Both of these numbers are at 99%. What that means is that my line is a pretty good fit. If this number is 1, that means 100%, which means that actually the line goes through all of the data points. This is a 99% fit because we do have a couple of points that are a little bit off. And so the higher this number is, the better. Now, your parameters here are what you're really interested in, because we know from y equals mx plus b that m means slope and b actually means the intercept, right? And so what we're given here is we're actually given an m and a b value. The slope here is 1.05239, and the b value is 8.74832. Now, those are not going to be nice because, again, my data is a little off here, right? And so a lot of times these numbers will be decimals, and what we want to do is we want to round them basically to the nearest hundredth. So I'm going to look at 2 decimal places here. So my line of best fit, I'm going to go back here. We're going to type in the equation, or we're going to type in the regression formula. And then step 3 is going to be to actually write an equation. So I'm going to write an equation from the numbers I've given. Now, remember, we're remembering y equals mx plus b. So when I write my equation, it's going to be y is equal to mx plus b, but now I actually have m and b values. My m value is 1.05. I'm just going to round it to 2 decimal places. So 1.05 is my m, and then of course x, and then it's going to be plus or minus depending on the sign of the b value. The b value here is 8.7. That 8 rounds this 4 up to a 5, so really 8.75. 8.75. And that is my equation of my line of best fit. This is the equation for the line. This is my slope value, and this is my intercept value that they give me. All right? The last thing that we're going to do with this set of data is make predictions. So, for the last part, we don't have very much room on our notes, but we can make it work. We're going to make predictions. All right. And so what if we are asked the question, now remember, think about the data we're dealing with here. We're dealing with hours versus distance, right? So I know that in 1.7 hours, I drove 10.4 miles. And same thing for 3 hours and 12 miles. And 4.7 hours and 13.7 miles. And in 6 hours, I was able to ride 15 miles. So if I want to make a prediction, I'm going to ask 2 questions. I'm going to ask what distance is traveled in 8 hours. And then the second question we're going to answer is how long would it take to travel 20 miles? All right. And so those are my questions. Now, we're going to look back at our data here. And so what we're really thinking is we want to know something about 8 hours. This first question, what's the distance traveled in 8 hours, right? Well, is 8 going to be an x value or a y value? Well, since 8 is in hours, my x values are hours. So I want to know something about 8. I'm just going to write it real small here. I want to know in 8 hours, what is this value going to be here? What is my y value going to be? All right, likewise, how long will it take to travel 20 miles? Well, think about 20 miles. Is 20 miles a y value or an x value? 20 miles is going to be a y value. And so what I'm really thinking is if 20 is in the y column, what would be my x value, right? And so here's how I'm going to solve those problems. I've still got in Desmos, I still have my linear regression line, I still have my data in here. All I'm going to type in the next line, I'm not going to backspace anything out. I'm going to keep the table in, I'm going to keep the linear regression line in, I'm going to keep all of this here. All I'm going to type in is that, okay, the distance traveled in 8 hours, 8 is an x value. I want to know what happens when x is equal to 8. And so in the next line, I'm going to type x equals 8. And I'm going to put that in. Now, may have to do a little bit of zooming out here. So you can either zoom out. I'm on a tablet, so I can use my fingers. If not, you'll have to use this zoom button right here. So see how my graph now has a green line at x is equal to 8. And you can actually see it down here. Yeah, I'm at 8, right, on my x-axis. What I'm going to do is I'm going to find the intersection between this line of best fit. Remember, this is the prediction line. This is showing me what my trend is in my data. As I go further and as time goes on, I go further and further in distance, right? So right here is my